Alright, wanted to explain the difference between mass and weight. And it is um, a topic that comes up in middle school and is can be very confusing, I think, for kids. So first, let's discuss what this term mass is, and we talk about that a lot in the science class, and it's good if we have a good idea of what we're talking about here. Mass is um, basically all the matter or the amount of matter of an object. All right, something like that. Other videos, teachers will say it's the amount of stuff inside an object. Stuff, very scientific. Um, or the number of molecules, or the amount of molecules of an object. And someday if you go into really high level physics, then this definition um, will will have its problems. But for us, this definition is perfectly fine. So it's all the matter of an object. And the reason that's important, let's say for instance, my mass was 100 kilograms. All right, and remember, we're in kilograms. We're not in pounds. We're not in ounces. We're metric here. So I'm 100 kilograms, and I'm 100 kilograms no matter where I go. So if I'm on Earth, if I'm on the Moon, if I'm on Mars or Jupiter, if I'm on top of a mountain, I am still made up of the same amount of this stuff. Right? I am who I am. I'm not going to lose a limb when I go from Earth to the moon or whatever. Okay, so my mass doesn't change. However, my weight is a different story. Okay, weight is actually a force. A force. It is the force of gravity acting upon my mass. So if you remember the formula for force, it's going to be force equals mass times acceleration. And in our in our topic of mass versus weight, it's going to be our mass times this thing called gravity. All right. So weight is our mass being pulled by the force of gravity. And so the force of gravity is 9.8 meters per second every second. And if you don't understand that, that's kind of a topic for another video, but um, just take it for granted that it's 9.8 meters per second or per second squared. And so that's our force of gravity, which is our acceleration, and we're going to multiply that by 100 kilograms, and we're going to get our force, which is going to be, well, 100 times 9.8 is going to be 980, and it's going to be kilograms times meters over seconds squared. And this thing is probably very confusing, but this is the same thing as something we call newtons. So my weight would be 980 newtons. Okay, that would be my weight. Okay, so my mass stays the same, and it would be in kilograms, and it would be the same no matter where I go, whether it be the Earth or on the Moon. And so on Earth, my 100 kilograms times the force of gravity, which is 9.8 meters per second, would then equal 980 newtons. And again, this would be a calculation of my weight. All right, again, this is my weight. Where am I here? My weight on Earth. Now, if we talk about my weight on the moon, that would be a different story. All right, so remember, my mass would be 100 kilograms because my mass stays the same no matter what. Okay, I'm made up of the same material, and it's not going to change. So this is going to equal my mass. And where Earth, let's see, Earth's force of gravity, Earth gravity, is equal to 9.8 meters per second, or per second squared. On the moon G, put that in parentheses I guess, is equal to 1.6 meters per second squared. So to find my weight on the moon, again, my mass would be the same, so that would be 100 kilograms times 1.6 meters per second squared, and that means my weight on the moon would be, and since I'm multiplying by 100, I'm just going to move my decimal point 2 times to the right, and I get 160 kilogram meters per second squared, and that is the same as 160 newtons. Okay, so again, mass stays the same no matter what. Let me change colors here. So mass stays the same no matter what. Alright, if I'm 100 kilograms, I'm 100 kilograms no matter where I am. But if I'm standing on the moon, then I'm going to be a different weight, because its force of gravity is pulling me down at a different acceleration. And Earth, I would have a weight of something else, because the force of gravity is pulling me down at that acceleration. Hope that clears it up. I'm sure you're a little bit more confused. Go to the second video. I'm kind of running long now, so I'm going to stop here, and I'll see you on the next video.